Greetings, mathematicians. Look at our table of contents. It is growing and growing. All right, let's take a look today. Hoping the date is correct. I'm recording these out a couple of days, so we might be off a little bit. Today's date, I'm assuming, is 8/27/20. Subtract. Unlike fractions. Page number 8 left and 8 right. And remember, we're talking about like and unlike. Unlike means denominators are what? Same or different? Unlike. Different. Excellent. Pause it if you need to get the title into your table of contents. Otherwise, let's get moving. Let's take a look at our page numbers. I've framed out some learning, but let's go ahead and be careful and be precise. 8 left, 8 right. Staying organized is a mathematician's best tool in finding the correct answer. All right, let's zoom in on our title bubble. Our objective here. And, what the heck? Let's stick with that magenta color. Let's make an I will statement off of our title. Unit 1, Lesson 8, subtract unlike fractions. So I will, what's our verb? Subtract. Take away, find the difference. I will subtract. Jump down here. Unlike fractions. What do you guys think? Should we do it one way or multiple ways? Yeah, it's always good to know our options. So I will subtract unlike fractions using multiple methods. All right, it's one thing to see it, it's another thing to know why it works, and let's not just stick with our algorithm. All right, our first example, we're going to reach back into our thinking from earlier lessons, and we have 2 fractions. So are they like or unlike? I've got 3/4 and 1/3, and we are subtracting. I don't know if you can see that. When we were converting, or when we were comparing fractions, we were using the opposite denominator. We were saying 3 times 3 is 9, 4 times 1 is 4, so 9 is greater than 4. We're going to reach into that and use our denominators as multiples. What are we going to do? Use our denominators as multiples. So first, we're going to distribute or multiply out. So we can take our first fraction, and I'm going to bring it down here. So we're going to say 3 times 3. 3 times 3 equals 9 over 3 times 4 equals 12. So I'm going to change, in the last episode, the last set of notes, we talked about changing both. Since we're going to change both of these, we're going to end up with a new denominator, so 9/12. Awesome, so 3/4 is now going to be 9/12. So let's hold on to that. Now let's go the other direction. Let me switch my color here. I'm going to take my 4 and distribute it this way. 4 times 1, 4 times 1, and 4 times 3 equals. And this should look a lot like using multiples, because we are using a multiplier. 4 is our multiplier, 3 is our multiplier. So 4 times 1 is 4, 4 times 3 is 12. Now we have like denominators. We can't do it when they're unlike, but now we certainly can. So let's go back to our original problem. Let's rewrite it with our new fractions. 9/12 minus 4/12 equals. Denominator stays. 9 minus 4 is 5. All right, so we're going to call this one using opposite denominators. As multipliers. This one will always get you to a correct answer. One of the biggest problems, though, is if you're using bigger numbers, there might be a smaller denominator that we can end up with. If you multiply really big denominators, your fraction will be correct, but it could be huge. And I have one example of that on the next page. All right. Next example, I have 5/8 minus 1/6. Mr. McNeil, those aren't really big numbers? Not yet. So if I were to multiply 6 times 8, what would I get? Think about your 8s, think about your 6s, however you get there. What's that number? 8 times 6, 6 times 8. Well, 6 times 6 is 36. We need 2 more 8s. Or, I'm sorry, 2 more 6s. So 36 plus 12, 48. So we could rewrite this as a fraction of 48, but it would be huge. Absolutely huge. So what I'm suggesting is first find the LCM. Say with me, LCM. And that stands for least common multiple. And we're going to do this by making a list. So first, let's grab our denominators. Let's say 8 colon 6 colon. And I might even want to do this with different pens. Let's do 8. So 8's, let's say we can go 8, 16, 24. You might find these numbers on a multiplication chart as well. 24. 8 more, what do we get? 32. 8 more, what do we get? 40. We can keep going forever and forever and ever, but what we are looking for is the first number that 8 and 6 have in common with multiples. Let's switch it up with my 6. 6, 12, 18, 24. I think I see a match. 24 is my least common multiple. So I found my LCM. My LCM equals what? 24. So now I know that I want to take my two fractions, and I'm going to move them vertically. 5/8 minus 1/6. I want to turn them into fractions of 24. All right. So how are we going to go about doing that? Well, we need multipliers. Multiplier. We need a multiplier. So ask ourselves, how do we go from 8 to 24? 1, 2, 3. 3 is my multiplier. 5 times 3, 15. Coming down to 6. 6 times what is 24? 1, 2, 3, 4. Multiplier. 4. 1 times 4 is 4. Now I have a problem with the same denominators. We have like denominators. Let's subtract 15 minus 4. We get 11 over, keep the denominator, 24. So that is a correct answer. If we had distributed out, this would be 6 times 5 is 30. 6 times 8 was 48. If we went the other direction, 8 times 1 is 8. 8 times 6 is 48. 38 minus 8 is, we could bring it down. 38 minus 8 is 22 48. Now, notice 22 48ths and 11 24ths, they are equivalent fractions. If you double 11, you get 22. If you double 24, you get 48. This is a correct answer, and this is a correct answer. This one is our smallest. So if we reduced it down to its smallest form, this is where we would get to. But the point is, you want to find that LCM sometimes. It's going to help you. Also, 6th grade. This is huge. Super helpful. All right, guys. I'm going to have some Prodigy questions for you. Probably 12. I like 12. 12 is a good number. This is something you have to do. Something that you might want to do. Classwork. Pages. 19 and 20. if you can't get enough of this skill and you want to practice even more, homework pages. Let's see, homework would be on page 15. Page 15. So I need everybody to do this, but if you want to work more at home, you've got your workbooks now. All right, guys, I'll see you when I see you.